Hello there, Nareg is here, and today I'm going to talk about again a small part related to quadratic equations. But in this case, whenever we have an equation which is in the irrational form, how can I transform it to quadratic form? So what do I mean by irrational? Let's start. Whenever you have square root of your polynomial p of x is equal to a certain polynomial q of x, how should I proceed? I will directly take an example and we're gonna solve it together. So let's say we had 3 minus square root of x minus 4 is equal to x minus 3. So in this case, you should first arrange and you should write down as 3 minus x plus 3 is equal to the square root of x minus 4, which means 6 minus x is equal to the square root of x minus 4. Now, what should I do in order to remove the square, the radical or the square root? I should take this whole equation to the power of 2. So 6 minus x to the power of 2 is equal to square root of x minus 4 to the power of 2. So I will obtain 36 minus 12x plus x squared is equal to x minus 4. I will rearrange it, so x squared minus 13x plus 40 is equal to 0. Now this equation, as you can see, it's a quadratic equation, so I was able to transform my irrational equation to a quadratic form. Now how do I solve a quadratic form? Very simple. I'm going to use the discriminant, which is of course delta. So delta is equal to b squared minus 4ac. It's equal to minus 13 to the power of 2 minus 4 times 40, so it's equal to 169 minus 160, so it's 9, which is of course positive. I have two distinct real roots, which is x1 minus b minus square root of delta over 2a, so it's equal to 13 minus 3 over 2, so it will be 10 over 2, 5, and x2 is equal to minus b plus square root of delta over 2a, which is equal to 13 plus 3 over 2, so it's 16 over 2, it's plus 8. Now what I should be doing is to verify if these roots are going to actually verify my initial equation. So I should check. Let's say we have this equation. It's the same thing as the first one. So is 6 minus 5 equal to square root of 5 minus 4? 1, is it equal to the square root of 1? Yes, 1 is equal to 1, so this root is acceptable. Now what about the second one? 6 minus 8, is it equal to the square root of 8 minus 4? Minus 2, is it equal to the square root of 4, which is 2? No, so this value is not acceptable. So this is how you solve your irrational equation. I'm going to take another example. So let's take one more example. We have square root of 2x plus 1 minus square root of x minus 3 is equal to 2. Now I'm gonna write it down in this way. So it will be square root of 2x plus 1 is equal to 2 plus square root of x minus 3. Of course, I'm gonna take it to the higher degree, second degree. So what I will obtain, square root of 2x plus 1 to the power of 2 is equal to 2 plus the square root of x minus 3 to the power of 2. So 2x plus 1 is equal to 4 plus 4 square root of x minus 3 plus x minus 3. You simply expand it by using the binomial expansion, a plus b to the power of 2, a squared plus b squared plus 2 times a times b. So I'm going to arrange it one more time. So I will obtain 2x minus x, so it's x, which is equal to 4 minus 3 is 1, minus 1 is 0, so it's 4 square root of x minus 3. Again, I still have a square root, so I'm gonna take it one more time to the degree 2. So x to the power of 2 is equal to 4 square root of x minus 3 to the power of 2. So I will obtain x squared is equal to 4 to the power of 2. It's 16 actually. So in this case it's 16 times x minus 3. So my equation will be transformed to x squared minus 16x plus 48, which is equal to 0. As you can see, I was able to find a quadratic equation. Now this quadratic equation, it has its b, which is even. In one of the previous videos, the first video related to quadratic equations, I discussed about the reduced discriminant, so I'm going to use the reduced discriminant. Delta prime is equal to b prime squared minus ac. So b prime is actually minus 16 over 2, it's minus 8. Minus 8, negative 8 to the power of 2. Minus a is 1, c is 48. So it's 64 minus 48. So it will give me 16. Delta prime is positive. I will have two real distinct roots. x1 is equal to negative b, so it's negative b prime minus b prime minus square root of delta prime over a. So 8 minus 4 over 1, so it's 4. As for the second one, x2 is equal to minus b prime plus square root of delta prime over a. So it's 8 plus 4 over 1, it's 12. Again, I should verify if these roots actually give me, actually they will verify the initial equation. So I'm going to take, let's say, this one. So let's check. Is the square root of 2 times 4, 8 plus 1 minus square root of 4 minus 3, is it equal to 2? So it's square root of 9, 3 minus 1 is actually equal to 2, so it's acceptable. As for the second one, square root of 2 times 12, 24 plus 1 minus square root of 12 minus 3 is 9. Is it equal to 2? So 5 minus 3, is it equal to 2? Again, I'm going to be able to find 2 is equal to 2, so it's acceptable. Both of these roots are actually acceptable values. That's all for this video, where we discussed how to transform an irrational equation to a quadratic one, and of course how to solve, and especially you have to remember to verify if your roots are actually the values that are verifying the initial equation. Why don't you subscribe to my channel? You'll be notified whenever I upload new videos, and I can also share with you my Instagram and Facebook account. You can contact me directly, or you can simply leave a comment below. I hope it was helpful and see you next time.